Welcome to Infinite Findings. As you settle in to watch this, something catastrophic is unfolding across the North American continent right now. Millions of people are watching their skies darken. Entire regions are suffocating under thick, toxic haze. Temperatures are reaching levels that experts once thought impossible. The ground is cracking, forests are disappearing, and this is only the beginning. What started as an ordinary summer has become something far more dangerous. A meteorological phenomenon of such power that climate scientists are using words like unprecedented and historic. When this crisis finally ends, and no one knows when that will be, it will have reshaped how we understand extreme weather. It will have burned areas larger than entire nations. It will have transformed the air that hundreds of millions of people breathe into something toxic and unrecognizable. But here's what experts are telling us right now. The worst may not have arrived yet. Today, we're investigating exactly what's happening across this continent, why it's accelerating, and what comes next. Because understanding this crisis isn't just about curiosity, it's about survival. Let's find out what's actually occurring and why the situation continues to intensify by the hour. Before we dive deeper, if you're experiencing this crisis directly, if you're breathing this smoke right now, or feeling this heat firsthand, we want to hear from you. Comment below and tell us where you are and what you're witnessing. Your first-hand accounts help us understand this story from every angle. And if you want to stay updated as this situation develops and changes, subscribe to Infinite Findings right now. We're tracking this crisis in real time, and new updates are coming constantly. A quick like also helps us reach more people who need this information. Everything began with an atmospheric monster. In mid-July, something extraordinary formed over the north-central United States. Meteorologists don't use sensational language lightly, but what they observed broke through their professional restraint. They called it the strongest ridge of high pressure ever documented in that region. Not in recent memory, not in the last century, ever. This wasn't just unusually hot weather. This was an atmospheric structure so powerful that it defied historical records going back generations. The heat dome didn't gently warm the landscape, it attacked it. Temperature records that had stood for decades, some for nearly a century, shattered in a matter of days. Places that rarely experienced dangerous heat found themselves in furnaces. Readings climbed past 100 degrees Fahrenheit in regions where such temperatures were once considered virtually impossible. The heat was relentless and unforgiving. But what happened in Canada reveals just how extreme this became. Thunder Bay, Ontario sits on the edge of Lake Superior, surrounded by water cold enough to refrigerate the entire region. This city has never been known for scorching summers. Yet, in mid-July, it reached 103 degrees Fahrenheit. That sounds dramatic until you realize it shattered the all-time heat record by over 2 degrees Celsius. For a place with well-established climate records, that margin doesn't just break a record, it obliterates it. Further north in Armstrong, temperatures climbed to 105 degrees. This was the hottest temperature measured anywhere in the entire province since 1936. Nearly 90 years of climate data, and this summer just erased that record. When meteorologists see something like this, they understand they're witnessing something genuinely dangerous, something that changes how we perceive our climate. Yet the heat alone was only half the story. The real danger came from what that heat accomplished to the land itself. For months, drought had been slowly strangling the forests and grasslands. The ground had become progressively drier. Vegetation that normally contained moisture had turned brittle. Soil that should have been damp was baked hard. Then, when that record-breaking heat arrived, something catastrophic happened. The heat sucked away the remaining moisture, transforming entire regions into landscapes primed for destruction. When forests reach that level of dryness, they become fundamentally different. A single spark ignites immediately. A lightning bolt becomes catastrophic. A power line sparking becomes a 3-alarm emergency. The forest stops being an ecosystem and becomes fuel waiting to burn. The heat didn't just make people uncomfortable. It transformed the landscape into a tinderbox waiting for ignition. And then, as if on cue, the ignition arrived. Canada entered a wildfire season that statistics alone cannot adequately describe. By late July, approximately 900 active wildfires were simultaneously burning across the country. That's not 900 fires that would occur over an entire summer season. That's 900 fires burning at the exact same moment, each one consuming resources, each one growing, each one sending smoke into the atmosphere. By that point in the year, nearly 4,000 fires had ignited. Collectively, they had burned through more than 3.3 million hectares of forest, farmland, and wilderness. For perspective, that's an area larger than entire countries. Completely scorched, completely blackened, gone. Western Ontario emerged as the most severely affected region, and it became the primary source of the smoke that would eventually choke millions of people across the United States. In the northwest portion of Ontario alone, officials confirmed well over 100 active fires at any given time. Dozens of them weren't being contained, they weren't being held at bay. They were burning freely, spreading across wild terrain that firefighters couldn't easily reach, consuming everything in their path. There's a factor that made these fires especially fierce and especially difficult to combat, and it reveals something unsettling about forest ecology. Many of these forests contained enormous quantities of dead wood already stacked and waiting. Some of it came from an infestation of spruce budworms years earlier. These insects had killed thousands of trees, leaving them standing dead and bone dry. Some of the dead wood dated back decades to a major windstorm that had flattened thousands of trees, which had then dried out on the forest floor over years. So when the extreme heat and powerful winds arrived, the fires didn't simply encounter living forest. They encountered a landscape that had been pre-stocked with kindling dry, ready, waiting to ignite. It was as if someone had spent years arranging the perfect conditions for disaster. And that's exactly what the fires found. This is why these blazes moved so quickly and burned so intensely. This is why firefighters found them nearly impossible to stop. Many fires were spreading through remote, inaccessible wilderness, where ground crews simply couldn't bring equipment. There were no roads. There were no landing zones for helicopters. Firefighters in those regions often had only one option: wait for rain. They had to hope that weather patterns would shift, that storms would arrive with enough moisture to slow the burning. It was a brutal position for people trying to contain an uncontainable force. But the situation wasn't limited to Canada. Across the border, the United States faced its own wildfire crisis. The western United States experiences devastating fire seasons regularly. The combination of extreme heat, drought-stressed vegetation, and powerful winds present in the summer of 2023 matched the exact recipe that had produced some of the worst wildfires in American history. From the Great Basin to the Rocky Mountains, fires were erupting and spreading across states already struggling with drought. The fire threat didn't respect borders or political boundaries. It encompassed an entire continent. Canadian fires dominated the smoke narrative, while Western U.S. fires added their own dangerous contribution, all of it fed by that same overwhelming continent-wide heat. Firefighting resources on both sides of the border were becoming critically stretched. In severe fire years, Canada and the United States typically send crews and aircraft across the border to assist each other. But when peak fire season strikes on both sides simultaneously, no nation has enough resources to handle it alone. Both countries were leaning on the same limited pool of experienced firefighters, specialized aircraft, and equipment. It was a shared crisis requiring shared resources, and those resources were running dangerously thin. Now here's the element that makes a wildfire crisis of this magnitude so terrifying. You don't need to be near the flames to be devastated by them. The fires produce smoke in quantities that are hard to comprehend. That smoke doesn't stay confined to the fire zone. Instead, it rises high into the atmosphere, sometimes traveling miles upward. Once it reaches the upper atmosphere, it catches fast-moving air currents that transport it across entire continents. Smoke from a remote forest fire in Western Ontario can reach the east coast of the United States within days. But understanding exactly how this happens requires understanding atmospheric physics. When an intense wildfire burns, something remarkable occurs. The heat generates enormous updrafts, columns of hot air rising violently upward. These updrafts can carry smoke many miles into the atmosphere. The most powerful fires can even create their own weather systems. They generate pyrocumulus clouds, specialized thunderstorm formations created entirely by the fire's heat. These clouds punch smoke into the upper atmosphere with tremendous force. Once the smoke reaches that height, it encounters jet streams and other high-altitude wind currents. These are the same fast-moving air rivers that transport weather systems and commercial aircraft across the continent. Those winds don't gently drift the smoke, they transport it rapidly. A plume of smoke from Western Ontario can ride these currents for days, traveling hundreds or even thousands of miles, eventually descending back toward the surface over cities that have no active fires anywhere nearby. Citizens wake up to hazy skies, difficulty breathing, and orange-tinged mornings, not realizing that the source is a fire burning 1,000 miles away. The physics of atmospheric transport means that fires in Canada became an air quality emergency across the entire eastern United States. The smoke descended over major cities. It blanketed the Northeast. Visibility in places like New York City dropped dramatically. The air turned hazy and thick. People reported struggling to breathe. Athletes and outdoor workers found themselves sidelined. Parents kept children indoors. Millions of people experienced days and sometimes weeks where simply stepping outside meant inhaling air so polluted that respiratory symptoms began almost immediately. This wasn't just discomfort. This was a public health emergency unfolding in regions with no active fires, no flames, no visible danger other than the smoke itself. Air quality measurements told the story. When the smoke arrived, air quality indices reached levels classified as unhealthy and hazardous. These measurements use a color-coded scale where green indicates safe air, and as the colors progress through yellow, orange, and red, the air becomes progressively more dangerous. During peak smoke episodes, many cities saw their air quality reach purple, the highest hazard level. This isn't theoretical danger. Real human bodies were experiencing real respiratory distress. Hospitals reported increased emergency room visits. Doctors noted increases in respiratory complaints. Vulnerable populations, children, the elderly, people with asthma experienced days where they couldn't safely breathe the air outside their homes. The science behind this danger is straightforward and terrifying. Wildfire smoke contains particulates far smaller than a human hair fine particles that penetrate deep into the lungs. These aren't like dust that settles on your clothing. They travel into your bloodstream, they trigger inflammation, they reduce oxygen uptake. Children are especially vulnerable because they inhale more air relative to their body size. Their lungs are still developing. Exposure during these ages causes measurable damage. When air quality alerts issue warnings about smoke, they're not being cautious or exaggerating. They're reflecting genuine, measurable danger to human health. They're telling people that breathing the air will cause harm. But here's what the experts kept emphasizing. This crisis wasn't approaching its end, it was still developing. The forecast showed a continuation of the same weather patterns. Smoke from active fires would keep flowing into the United States through August. As long as those hundreds of fires kept burning, as long as many remained completely out of control, the smoke would continue moving. New episodes of hazardous air weren't possibilities, they were forecasts. They were coming. The fire danger itself wasn't diminishing either. Even in regions where rain had temporarily relieved conditions, the underlying fire danger index remained elevated. In Ontario, official assessments classified the danger as high to very high. Here's where it becomes cruel. The very thunderstorms that deliver some rain also deliver lightning. That lightning starts new fires. So the weather that temporarily helps firefighters also creates the next generation of blazes. It's a contradiction that makes fighting this crisis particularly difficult. Most critically, the heat wasn't finished. The same type of atmospheric pattern that ignited this crisis was forecast to persist and even intensify across the continent over the coming weeks. Official fire assessments for August highlighted broad regions where conditions would continue to favor increased fire activity. The underlying conditions that created the disaster remained in place. The fuel was still dry, the fires were still burning, the smoke was still flowing, the heat was still building. Every single ingredient that had created this catastrophe was still present. That's why experts stress so firmly, this is not over. There's a deeper reason the long-term outlook remained concerning. Drought doesn't vanish because a single rainstorm passes through. It took months of heat and dry conditions to transform the landscape into the tinderbox it had become. Reversing that requires sustained rainfall, not passing thunderstorms. A brief downpour might temporarily reduce fire danger, but it doesn't erase the underlying dryness that primes entire regions to burn. The welcome bursts of rain that had given firefighters temporary relief in certain areas did nothing to eliminate the fundamental condition. Dry landscape, dry vegetation, ready to burn. Meanwhile, fire agencies were issuing monthly assessments highlighting broad areas where increased or continued fire activity was expected through August. Peak fire season across much of North America typically runs through late summer and into autumn. Statistically and seasonally, many regions hadn't yet reached the worst conditions. Fire experts often describe a landscape as loaded, meaning all the conditions are present for major fires, and the question isn't whether significant fires will occur, but where and when they'll ignite. Lightning from summer thunderstorms is a leading cause of new fires in remote regions. The situation was self-perpetuating. It could keep generating fresh blazes even without human involvement. All of this pointed in one direction. This was an ongoing crisis. It was evolving. It wasn't finished. The coming weeks would determine how many more acres would burn, how much more smoke would be generated, and how many more millions of people would experience unhealthy air. The question wasn't whether the crisis was over. The question was how much worse it would become. For people living through this, practical information became survival information. First, you need to monitor your local air quality constantly. There's a standardized measurement called the Air Quality Index, or AQI, that you can check on weather applications and government websites. It uses a color scale where green means safe air, and moving through yellow, orange, red, and finally purple means the air is becoming increasingly hazardous. When your area shows unhealthy air quality, take it seriously. Adjust your plans. Change your activities. The numbers represent real danger. Second, when smoke is heavy, stay indoors as much as physically possible. Keep your windows and doors closed to prevent smoke from entering. If you have air conditioning, run it ideally on a recirculation setting that filters the same air rather than pulling in outside air. If you have an air purifier, use it. The right filter can dramatically reduce indoor particle pollution. Creating one clean air room in your home, where you spend most of your time, is a smart strategy during extended smoke events. Even a low-cost option works. You can attach a quality furnace filter to a standard box fan to create an effective air cleaner for a single room when commercial purifiers are unavailable or expensive. Third, if you must go outside during heavy smoke, wear an N95 respirator or equivalent mask, not cloth masks, not surgical masks. Those provide minimal protection against wildfire smoke. You need a specifically designed respirator that filters fine particles. The difference between wearing the right mask and the wrong mask is substantial. Fourth, pay special attention to vulnerable people in your life. The elderly need to remain in clean air environments with access to their medications. Young children shouldn't be exposed to unhealthy air when possible. People with asthma, lung conditions, or heart problems need to remain indoors and maintain their medications. If they experience severe shortness of breath or chest pain, seek medical help immediately. Don't delay. These aren't exaggerated precautions for these populations. They're protective measures against genuine risk. Fifth, if you live in or near an active fire zone, take every evacuation warning with complete seriousness. These fires move fast, especially when heat and wind are extreme. When authorities issue evacuation orders, move immediately. Don't wait to see how close the flames approach. Prepare now. Have a go bag packed and ready. Know your evacuation routes. Understand where you'll go if you need to leave quickly. And remember that in many places, this is simultaneously a heat and smoke crisis. That means staying hydrated, finding cooling during peak heat hours, checking on neighbors who are vulnerable, and never leaving children or pets in hot vehicles. The combination of extreme heat and dangerous air makes indoor, cool, filtered spaces the safest refuge. Here's the unvarnished reality. The heat wave that baked North America this summer wasn't merely an extreme weather event. It was the catalyst that ignited a continent-spanning catastrophe. Record-shattering temperatures, some of the hottest ever recorded in the region, transformed forests and grasslands into extremely dangerous fuel. Hundreds of wildfires erupted, particularly across Canada, burning millions of hectares of landscape. These fires generated enormous quantities of smoke that spread across thousands of miles, smothering tens of millions of people across the United States with air pollution at levels some had never experienced in their lifetimes. This is a genuine continental-scale emergency. It's a fusion of three interconnected crises: extreme heat, widespread fire, and pervasive smoke. The consequences reach far beyond the flames themselves. They affect people living hundreds of miles from any active fire. They disrupt normal life, restrict outdoor activity, and damage human health. With fires still actively burning, smoke continuing to drift across the continent, and additional heat forecast to build in the coming weeks, experts are emphatic. This emergency is not behind us. It's ongoing, it's developing, it's intensifying. The days and weeks ahead demand constant vigilance. Monitor your local air quality, protect yourself and your family from smoke, respect the heat. If you're near active fires, maintain readiness to evacuate immediately. Stay safe, stay informed. Look out for the people around you. Infinite Findings will be tracking this crisis every step of the way. The fires, the smoke forecasts, the air quality measurements, and the heat as it continues to evolve across North America. If you want to follow this story as it unfolds and stay informed during this genuine emergency, subscribe right now. The situation is changing by the day, and staying informed genuinely matters for your health and safety. Like this video so more people see it. It could help someone protect themselves. Comment below and tell us where you are and what you're experiencing. We read every single comment, and your perspective matters as this crisis continues to develop. Thank you for watching Infinite Findings. We'll see you in the next discovery. Stay safe out there.